What's going on, everybody? Welcome back to Living Electric. Brandon and I are here with a special guest, Jeremy McCool from Hevo. So I'll pass it over to Jeremy. Give a little intro.
Alex, Brandon, great to be here. Thanks a lot for inviting me on. I'm Jeremy McCool, founder and CEO of Hevo. We are a pioneer of wireless electric vehicle charging and software products. We've been at this now since 2011, headquartered out of Brooklyn, New York. And we've got some really excellent news to be talking about today, so it's good timing. We have projects across the globe on 4 continents, and right now everything is focused on the key challenges that we're needing to meet to commercialize the technology, to meet the product roadmaps that customers want from us, and really at this point to scale to meet the needs of those customers. So really excellent time to be on here, and looking forward to the discussion today. Thanks.
Definitely. Yeah, we've been doing a lot of research on Hevo, and I'm very, very excited. I actually missed an opportunity. I met you briefly at Fully Charged Live in September.
Yeah, we did.
I don't know if you remember that. It was a very, very short conversation, but I never got a chance to go back to your booth. So very excited to learn about your technology.
Yeah, it was, everything was kind of fast moving during that couple of days anyways, but all the same, it's been an amazing journey to be on. Wireless EV charging has been kind of shuffled to the side a little bit over the last 5-6 years, and as things have started to come back around, now that electrification is really starting to take shape, it's coming back straight to the board because people want a better user experience, but even more, what it can do to make charging electric cars just much more efficient. And so timing is always the most important thing for anything, especially with a new innovation like this. And we feel like the timing is finally where it needs to be in order for us to get this moving forward and getting it into people's garages. You may already know this, and I think you do as well, Alex. We focus right now on fleets. So the key types of fleets that we're really honed in on is on the logistics side, transit side, and accessibility side. And there's a reason why, because at the moment, there's major companies around the globe that are logistics, transit, and accessibility, or in other words, disabled driver-related fleets that are starting to really mobilize at a rate that we've never seen before in terms of electrifying their vehicle platforms. And it's an interesting story that always comes up. What are they going to do for the EV charging? And they usually don't have a really strong answer to that. But they do know that cords are going to be a hindrance of some sort to them, whether that might be because of upper and lower mobility issues, because disabled drivers won't be able to pick them up, or because of standards around safety and OSHA standards that won't allow them to have cords laying around fleet yards and depots, or even the other story that doesn't come up enough, which is that they may be restricted to plug in terms of the drivers being able to plug in because of union labor requirements. So these kinds of things are what are driving the model for wireless EV charging around the globe. And we see that as a stepping stone to the eventual phase of it getting into also people's home garages and becoming a consumer good as well.
Well, it's amazing the small details that I think a lot of people take for granted when it comes to EV charging, specifically with cables. Those cables are not light in any way. And actually, Jeremy, I follow you on LinkedIn, and you had posted something I think a few months ago regarding your mom with accessibility and how heavy certain cables are, and how some people that might not be able to lift those, how wireless charging is going to change their lives. And that's why I'm really excited about talking about this today, because I really think a lot of people take a lot of that stuff for granted when it comes to EV charging.
You're absolutely right, Brandon. And in fact, there's about 10 to 15% of drivers around the world that qualify into that mix. The single largest fleet in all of Europe is a fleet that's wholly focused on disabled drivers in the UK alone. There's about 2 million disabled drivers in the UK. One fleet is responsible for licensing, leasing, financing vehicles as part of a bigger UK government-related type of project. And they've got 650,000 vehicles that are already under management, and they have to convert all 650,000 of those vehicles to electric by 2030 as a UK mandate. Well, they started to already put out about 10 to 13,000 electric cars to get drivers that could potentially drive them, using them, and see what the testimonials were. And obviously the first thing that came back that was the challenge was being able to lift the cord and plug it in. And so when we start to think about that also from just also logistics and transit companies that have drivers that have some level of upper or lower mobility issues, they also are going through that same kind of challenge and trying to figure this thing out as well. And just the seamlessness of the interaction. It's not something normal for fleet operators and managers to figure out how to make plug-in charging work or make EV charging work. They don't speak in kilowatts, right? So they need something that's just really easy for them to be able to manage. It's out of the way. It doesn't cause hazards. Anybody can do it, and that's what wireless charging brings to the table.
Right. Yeah, I wanted to get into kind of more of the technical details for a little bit, hopefully nothing too in-depth. I know I'm an engineer, Brandon's not, so we kind of balance each other out on the podcast of kind of making sure we're appealing to everybody. But could you talk about kind of the HEVO technology, maybe how it differs from other wireless charging, why it's special, that sort of thing?
Yeah, and just up front, I'm also not an engineer. So when I founded this company, I came with the least amount of experience and expertise required to develop a company like this.
Right.
But through the last decade, I've caught up on that quite a bit. So
right.
Wireless charging for electric cars is a little bit different than charging for your phones. And so that's what usually is the analogous kind of comparison that goes on back and forth, and it's not the same. And there's something to that point, and I'll get to that. So first is that plug-in, or I should say phone charging wirelessly is done through induction. And it's just a kind of a brute force, old type of technology that's been around for transformer technology and things of that nature for 100 plus years. Thank God for people like Nikola Tesla that helped us to get to that point and create alternating current and all these things, right? And in fact, the funny thing is anything that's a cable that induces energy on it does have a field, and it has an AC level field, right?
Right.
And so if it's a straight line like a cable, well, that field is just kind of like going all over the place and then it dissipates. But if you take that and you coil it up into a circle or a square or some other kind of, we'll say, resonant source like that, you can then transfer power like a beam. And that's what happens with phone charging or even induction stoves to a degree as well. So the difference is that we resonate on a frequency that's typically fixed around 85 kilohertz. And that frequency is the global standard for wireless EV charging that was adopted around the globe by all major automakers and all regulatory requirements to do so. It's outside of the normal, we'll say, frequency band that would happen to potentially create some kind of emission issue where it could create, things like what comes up, for example, what happens with people's pacemakers. Well, the pacemakers are on a completely different frequency. And the other thing that's the upside to this, at that specific frequency, we happen to see a very high efficiency rate from end to end. So what it does is it helps to improve end-to-end efficiency, ensuring that it's not creating interference with other types of electrical systems or computer systems or pacemakers or anything of that nature. And it's also in a frequency band that is safe for humans and biological organisms, so that if you come within that field, it's not going to create some kind of disability or other kind of epidemiological issue. So what kind of efficiency are we talking about here? Well, from end to end, the way that we measure is from the grid source all the way to the battery. That's the real way that you should measure efficiency, because that's the transfer losses and everything that comes from that's taken into account. And when we do that, we see wireless charging in general, HEVO and any of our competitors included, having somewhere between a 5 to 10% loss from grid to battery. When you do that with plug-in charging, the loss is somewhere between 3 to 10%. So we're right about the same rate of lossiness, if you want to put it that way, or efficiency that you get with plug-in charging. So at this point, it's really, it's not something that is completely non-trivial, but it is at this point pretty close to parity. And the other part of that is also around what we can do in the form of improvements to this. And so one of those things that comes up often is, does it charge at the same power level that you can do with plug-in charging? Well, the answer is yes, and can even do more than what we do. So currently, if you look at consumer brands around the globe, there's only a small handful of vehicles actually that are electric, that are consumer brands or light-duty passenger vehicles that can charge in the 300 kilowatt level of range. And I'll explain what that means. So with the level 2 charge, which is considered overnight charging, usually that's going to be somewhere in the range of 6 to 11 kilowatts. And for every kilowatt, you can expect somewhere around 3 miles per kilowatt gain. So what that means is if you're charging in a range of 6 kilowatts, you'll gain 18 miles in 1 hour of charge. If you're charging at 11 kilowatts, you'll gain somewhere in a range of 30 to 33 miles of charge. So that's what that equation looks like. When you're doing it at 300 kilowatts, you're adding a range of almost 1,000 miles in 1 hour of charge, which, by the way, is not the best thing for the battery. It prefers to be charged in that more overnight type of range, which is why 90+% of charging will continue to be overnight charging, whether it's at somebody's home or it's in a fleet yard with a depot that's charging logistic vehicles and transit vehicles overnight, or it's also just publicly available at curbside. And it uses the type of power that is normalized for grid systems. So in most grids around the world, you can find 208 to 240 volt AC very readily available and in a range of, say, 30 to 50 amps on that, which would give you a range approximately between 6 to 11 kilowatts. So you don't have to go through these major upgrades to increase your power. However, we understand that people don't want to be sitting all day long idling and waiting to charge all day while they're in a long distance type of route. So there is available existing plug-in charging today that can charge vehicles up to 350 kilowatts, but there's only a couple of vehicles in the world that have the battery chemistry that allows for that to happen. So as an example, the Hummer Super Truck is one of the ones that claims to be able to do that. The Lucid Air is another one that claims to be able to do that, but there's not many other ones out there today that can do it, and there's a reason why. Because the battery chemistries are not built to be able to go faster than that. They will be, and we're going into a phase of new battery development that's happening around the globe that will give consumers, drivers, fleets, and everybody the ability to charge at a much higher rate, but that's not today. So what do we got to do to make it work today? It's very simple. We want to make sure that you can charge 90% of your vehicle, which is our first offering, by the way, an overnight charger in the range of 7 to 11 kilowatts. We offer that today. That's our first commercial product. We're the first company to ever bring a Society of Automotive Engineer, or SAE, and Underwriters Laboratory UL certified system to the market. And we're working towards already with one of our development partners, Oak Ridge National Labs, which is the wireless EV charging development arm of the Department of Energy. HEVO and Oak Ridge have a partnership together in which we're working to bring high-power 300-plus kilowatt wireless charging to the market that not only charges the vehicle while it's standing in place, but also while you are driving as well. And we're demonstrating that technology this year in the Detroit metro area.
That's
very
incredible.
Cool.
Yeah, and I also have to say that was all spoken like an engineer, so...
Well, hopefully you were able to follow it. I did my best to give as much nuance to that as possible for people to be able to follow.
No,
for
definitely.
Sure.
Alex has taught me a lot by us doing this podcast.
Alex will teach us about some stuff today, too.
Yeah, we've done some walkthroughs when we're not recording, so... Yeah. So, Jeremy, I do have a quick follow-up question for that 300 kilowatt wireless charging. So I know that there's like a lot of misconceptions and stigma regarding wireless charging. As you mentioned earlier, it kind of falls to the wayside, especially, as more networks are coming live with like some, plug and charge with cables and so forth. With your new product of like 300 kilowatt wireless charging, I've never heard of a product like that before. Can you provide some more details on that and how HEVO is fighting those misconceptions of wireless charging? I think that would be important to talk about.
Would love to, Brandon. Thank you for the opportunity, because we do get it a lot. One of the things is always about the efficiency. So that comes up the most often kind of I would say, neglect to understand what wireless for EV charging is that people just automatically assume it's the same kind of technology that's being used for phones and for other kinds of devices like that. It's not. And the efficiency is just so much different. A phone charger will have somewhere between like 60 to 80% efficiency. You totally get that point. But for EV charging, you cannot have a certified product that's under 85% efficiency from end to end. And at this point, I will tell you this, any competitor in the space is at 90% or above. So we are a highly efficient industry, not just Hevo, the industry. Now, when we think about the higher power levels, it's not enough to think about from the point of view of, hey, like, let's push more power into the vehicle just to get it moving and onto the road again faster. We got to think about it from the point of view of also there's equipment on the vehicle end that has to go into it to receive the vehicle charging and then put that into the DC battery bank that's on the vehicle. And so we have a system that's on the vehicle side that operates like, just think of it this way. The wireless charging mat or pad on the ground is kind of like a giant, bigger mat version of your mobile phone charging mat, right? And just like your phone, you have to have a device in it that receives that power. You won't just do it automatically. Well, it's the same thing with vehicles. And so there is an onboarded system that we call the vehicle assembly. And it has a battery adapter that connects directly to the battery that's receiving the power and then gives it a DC output to the battery. So the battery really wants DC. That's what every battery wants. It wants DC power or direct current. Right. So we are supplying as a part of our different types of switches that happen between inverting from AC to DC and DC to AC and all those things. We are supplying DC direct to the battery the way that it wants it to within the voltage and the current requirements. And it's the same thing. You have to have that for plug-in charging. You can't just plug your vehicle in and then it just automatically receives a charge to the battery. There's this common thing that has to go through, and a lot of it is safety requirements, so ensuring that there's communications between the source that's providing the power and the vehicle in, so that's happening. So it's telling it, hey, I'm ready to receive a charge. This is the voltage I want. This is the current that I want. But then there's some other nuances with wireless charging. With a cord, you have a direct connection, right? So that communication is connected. We are doing that wirelessly. So we have to communicate between pad to pad wirelessly or device to device wirelessly. And what that relates to is there's a common also communication system to wireless. And this is why wireless is so unique in EV charging in general, is because it's one common universal standard. Rather than having all these different plug-in charging connector types and some of these things that you have to do to bring an extra connector with you. I don't know if you guys have seen it. Have you guys seen the charging station adaptations that have been done to the Tesla chargers for making them readily available for other vehicle platforms and models? Yep. So I was watching this video by Marquise Brownlee that was uploaded onto Twitter. And it had, I don't know if he staged it or what happened, but there was like 6 different models of vehicles that showed up to this one charger that's just north of New York City. And there was like a Rivian that had to get in and park itself in a way that was taking up extra additional spaces. And on top of that, I think a Lightning showed up, and it was basically pulling and tugging on the DC, that high power DC cable from the Tesla station, almost like it was going to rip it out. Right. And so this is the problem, guys. Like, okay, well, you can't universally fix this because, different automakers are putting those charging ports in different locations of the vehicle. And they have different connector types. And different power types means thicker cabling. So if you want a high power charge, you're going to have to get a really thick cable. And some of those cables are as thick as my wrist. And so we're talking about 50, 60, 70 pounds worth of cabling. And there's just so much easier ways to do that with wireless. There's one simple methodology. Everybody has, if you have, no matter what technology for wireless that you have on your vehicle, just like with your phone, you can charge at any wireless charging station universally because all the common communication systems and all those things are being utilized between all competitors in the space. One last thing to note about wireless and how we go about it. So wireless charging is is typically measured in a metered squared kind of version. So that pad that's on the ground, it's basically 1 yard by 1 yard, or for our friends in metric, 1 meter by 1 meter. That, right?
Right.
And so, and it's commonly about 2 inches thick, or roughly 4 cm thick. Again, for our metric folks, and so that means that this pad is kind of universally sized. Everything is universally built to universal specs that are automatically expected by automakers. And so, with that stated, what HEVO has done with our partnership over at Oak Ridge, that pad that's on the ground, we're able to power 8x more than any of our competitors in a 1 meter by 1 meter space. Let me put that into terms for people. So our closest competitor with 1 meter by 1 meter can do 160 kilowatts. And that's, by the way, that's amazing.
Right.
You're looking at 450 miles of extended range with a 160 kilowatt system. But our models for our 1 meter by 1 meter square says 1.5 megawatt. Let me put that into terms. That means somewhere in the range of almost 5,000 miles in 1 hour of charging. Right. And so the cost efficiency and the speed and the time efficiency is only going to be limited by the battery chemistries and technologies as they start to advance and allowing us to charge them at higher power.
Gotcha. So you mentioned like the kind of communication and stuff. Is there and I guess the cable problem as well that we're having with just plug-in vehicles, is there a range that you have to be, within the wireless charging pad to receive that energy at the appropriate power? Is that part being standardized on vehicles as well, where it's like, hey, this receiver, if you will, has to be on this position on the vehicle? Anything like that being standardized as well?
Yeah, and I hope I didn't leave Brandon behind on that conversation. So
no. I just normally
I went deep into a little bit of that tech side of it, but to answer your question, Alex, is that there is a relationship between where the vehicle pad is on the vehicle side versus where the ground pad is in the ground. So what has been universally adopted is that the vehicle pad will be either retrofitted as an aftermarket solution or factory built in, to be placed in the front third of the vehicle between the front 2 tires, approximation. Okay. So, and then with parking, the parking pad, if you were thinking of it of like coming straight into like a parking space with like a little curb bumper for the tires, that would also be the same thing. So you would either pull forward and kind of hit those bumpers, and it's going to be normally in that kind of range of where it is, and or the other option to that is when you're pulling into like a curbside parking, think of New York as an example, right. Curbside parking where you're parking in parallel, then it'll be in the front third of that space. But there's better options out there for that too, which is that it'd just be better to take that whole that curb side, I should say, where they're parking at underneath the asphalt, and add in a whole strip of just charging there for wireless. So you pull in and it's just automatically there. Wherever you're at is where you're receiving power, and it only turns on in that one specific section where you happen to be parked at. So you don't have to, come up with some kind of weird solution about only these size cars can park on this curb side. Right. We don't want that to happen.
Gotcha. And is that kind of equivalent to the on-road scenario, if you will? Is it basically just a big long strip of kind of these transceivers or transmitters, if you will?
Yeah, exactly. So when we're actually moving forward in this current project, the way that it operates, think of it more of in almost a Lego block set type of format. So 1 meter by 1 meter, we can even do it 2 meter by 1 meter, and so each one of those get kind of installed under 2 to 4 inches of asphalt, and it becomes the sublayer underneath the asphalt, which is typically used for cement instead. So we are able to, with a cement resin base type of material, basically replace that cement underlayment that is always underneath asphalt in general. And because it already has this copper winding inside of it, it's already, in terms of structural integrity, it's already stronger than what you would normally see from something like an underlayment with some typical rebar and things of that nature. So it's a very easy way to drop it in, and you can just kind of continue to surface over the top of it. The other side of that story, though, Alex, is that because it's just basically copper and some ferromagnetic material,
Right.
this stuff will outlast all of us. Like the replacement requirements to this is superficially easy to say, like 20 plus years easy. And I would just tell you, it is as long lasting as I would say, like the conditions that we already see from things like induction that is measuring traffic in roads, that doesn't get replaced. So whenever we see those counters on the side of the roads that says 3,000 cars have passed here today, what's often being used is induction in the road to count vehicles passing over, and that doesn't get replaced. Or think of it from another point of view is never having to replace a cord because you don't have copper just laying around being ready to be ran over a cliff or
Right.
vandalized or something else.
Right. And one more question on the communication side. You mentioned, voltage and current, kind of translating that piece. Is there it built into the standard things for, payment, like identifying vehicles, things like that are, important for public sphere, but also fleets that want to know, where is my car parked? Where is it actually charging? Not just, charging it.
Yeah, the digital wallet of the vehicle will become the thing that replaces everything. So
Right.
all these third-party apps, that will go away. Your vehicle will be your digital wallet. And thank God, by the way,
Yeah.
because it's awful.
We preach it all the time here, too.
Well, Hevo developed a new app called Journey. So
Okay.
we went forward as EV drivers. We have experienced for the last decade the real challenges of public charging. Anybody that's actually done public charging, I'm not talking about only Tesla. You got to get out there and try them all out.
Yep.
You start to really understand that this won't work for mass adoption really
Right.
fast because it's just a lot of nuisances and all kinds of other things that happen while you're doing it. And a lot of the key problems that also happen with third-party apps is that they're not able to tell you what the state of charge of the vehicle is while it's charging. You're not able to do payment systems with it, and if you are, it's limited to only to that network. And then there's a couple of other things that always pop up, and one of those things is also we know that people typically state range anxiety as the problem of EV adoption, but we believe it's actually charging insecurity because that's what
Right.
we get back as the feedback from customers all the time. They're not concerned about EV charging. They know if it's there and they know how to use it, they're going to use it. But it's about how do you get there? Where's it at, by the way? How much is it going to cost? Do I have the right connector type? Am I going to actually make it there? And so that's what the Journey app by Hevo does. We eliminate charging anxiety or charging insecurity. And the way that we do that is that from any vehicle platform, doesn't matter what it is, so any vehicle model with using any kind of charging type, that with a driver that wants to use any type of charging network, it doesn't matter. The entirety of North America, we have all public charging stations in our app. And you can plan it just as normal if you were driving using Google Maps or Waze or whatever. You touch a point on the map or you put in an address or whatever it is. You search and use it the same way as all those platforms. But the difference is that it's taking into account your electric car and all the driving profiles and things like your aggressiveness of driving and all these things. And then it's calculating for you, if you're going to go do, a longer term journey or something like that, all the individual stops that you need to stop at, where they're located at, their addresses, what kind of charger they are, how long you're going to stop for, how much it's going to cost you. We spot price it ahead of you in terms of what the energy cost will be. And so we eliminate all this ambiguity of the challenges that we've faced personally as drivers. We kind of built it for ourselves, and then we were like, hey, we actually have something here that actually might service other people. And so far, everybody that has ever seen the software or used it has said it's the single best EV charging app that they've ever seen. And we're going to put a beta test out there with a much larger group in the next couple of months. So we'll be able to provide deeper testimonials and data points to that. But thus far, major automakers, major tier ones, and all of our customers that have been piloting our technology over the last half decade plus, every single one has said this is the best software for EV charging that we've ever come across. So let's put that into people's hands, and then we'll come back to the team here with some data points about how other people feel about it as well.
Wow.
And it's wireless ready. So back to your point, Alex, the communication side of it is that if you happen to have an electric car that is wireless, here's the upside, especially if it's a HEVO charging station, we reserve that station ahead of your arrival so that you're not sitting in a line waiting to try to figure it out. So 15 minutes ahead of your arrival, that charging station is locked out. Nobody can use it. And there's literally a lock on it that says reserved. So people don't accidentally try to pull up and charge on it and do stuff like that. So if you're pulling up on it, when you're within about 200 meters or so, there's a reservation number that's displayed on the power station, on the charging station, and there's a reservation number displayed on your mobile app. And so that you know you're matching up with the correct station that was reserved for you. Once you're within the last 10 meters or so, parking alignment automatically comes up on the app and on the screen of the power station. You've got two options of displays that you can look at, and it assists you in that last part of the approach with aligning your vehicle as accurately as you can over the pad so we can get you the highest power and efficiency level as we possibly can provide to you. So the communications and standards to these things have all been being built, and Stellantis, who we announced a partnership with in the last few months, their key engineer that's working with HEVO is the chair of all the primary bodies responsible for the universal communication standards for wireless EV charging.
Gotcha.
That's great.
So people are in the right location.
Yeah. Right. I was going to congratulate you, Jeremy, on that partnership with Stellantis. I saw that announcement a few weeks ago. That's incredible.
Yeah, thanks a lot for it. We actually, it was really funny because we have other ones that we haven't been able to announce, other big companies that are just waiting for for their media and PR teams to give us the green light. And they came
right.
back to us and said, wait, how did you guys get this with Stellantis? And we were like, well, Stellantis really was convicted and committed to getting this done. And the reality is that they're doing it because they've got, first thing, the fourth largest automaker in the world. That includes the brands of everything from Chrysler, Fiat, Dodge, Peugeot, Opel, Maserati, all these different vehicle brands and platforms. And by the way, they are skyrocketing in terms of deliveries. At this point, if you look at the profit margins of all the competitors in the EV space, so electric car manufacturer space, Tesla's number one, and Stellantis is just a smidge underneath them in terms of being number two. Right. So these guys are doing something that's different than most other competitors out there in the space. They're doing it very, very well. And therefore, they're bought into the idea of improving the user experience around EV charging because that's been the feedback that they've been receiving. And so they've got this ProMaster program that is the RAM, style, like electric vehicle shuttle / bus or van. And that is going to become something that is going to be a bit of a universal type of vehicle platform that people will potentially be able to use with wireless EV charging. So if you're a fleet and you're listening to this podcast right now and you think that that kind of package will help to suit you, by all means reach out because right now we're working towards what vehicle platforms would be introducing wireless charging from Stellantis first. And we think that could be a great one, but we need to obviously showcase that in the form of big fleets that want to utilize that as well.
Definitely. Well, looking over the list of the questions, I think we got everything answered.
Yeah.
Well,
yeah.
I did my best to at least give you guys some of the open stuff, but there's some new stuff on the line. I could talk about just real quick if you guys got just a moment here.
Yeah, definitely.
Sure.
Love to hear about it.
So some new news from HEVO. First and foremost is that there are some upcoming announcements that we are going to make regarding some of the biggest charging networks in the world and some of the biggest electric manufacturers in the world, electric vehicle manufacturers in the world, and then partnering up with HEVO. So we're looking forward to making those announcements. We need people to keep tuned in with us via social media and these kinds of podcasts because this is where we're gonna share that news at. And what I'll tell you this is, Getting one of the biggest charging networks to subscribe on to wireless charging is one of the most important next steps the company can make. And there's a reason why, because now we've got one of the biggest automakers on board with us. We also have Lightning eMotors, which is one of the biggest vehicle manufacturers in the form of Class 3, 4, and 5 vehicles in the United States to date. And I would also state that with a charging network, especially one of the top 2 or 3 biggest ones in the country and effectively in the world, that this is going to give people a notice that, hey, wireless is here. Everybody's being very supportive of it. We're very grateful to that point. And we need customers to tell their dealerships and to tell their automakers of choice that they want the wireless charging, because that's the sure win way for us to get you what you want, which is a much easier and simpler way to charge your vehicles. So, stay tuned. We've got some great news coming up very soon, and can't wait to make those announcements together down the line, Brandon and Alex.
Yeah, definitely.
Awesome.
Well,
Very cool.
Jeremy, before we wrap up, can you give a shout out of where our listeners can find more information about Hevo?
Yeah, absolutely. Hevo.com. That's our website, but also follow us on LinkedIn, Twitter, and Instagram, Facebook. We're on it all. And so we're very active. We're constantly providing updates. I'll tell you this, if you find some news that you like about Hevo, please share it. But also, if you have interest in Hevo, please reach out. We'd love to hear from you.
Definitely.
Awesome.
Yeah, appreciate having you on. I do want to say too, I know we've talked about wireless charging previously on the show, and in the past I've been very negative towards it because I've been imagining inductive charging this whole time. And I'll be honest, until I started doing some more research on Hevo and some of these other companies, I wasn't even aware of residence charging. So it's good, hearing there's this other option out there. It's not all, bad news, I guess, as I kind of initially thought. So definitely have opened my eyes a lot more over this past, show, kind of learning more about that. So we appreciate that.
One down, 7 billion to go.
Right. Exactly.
It's always good to learn new things. So we appreciate it, Jeremy.
Hey, thanks a lot, guys.